Probability is wide. So we're going to look at this question, but before we tackle this question, we will need to firstly understand a few axioms of probability, a few properties of probability. So probability will always range up to 1. So meaning the range for probability should be probability such that it's between 0 and what? And 1. For example, space 2 hold. So to unite is to add. The probability of A and B is simply the probability of A plus the probability of B minus the intersection of A and B. So this means that if you want to make A intersection B subject, how does it become? A intersection B therefore becomes what? This guy comes this side and this guy flies over the other side. The probability of A plus probability of B minus what? Probability of A union B. So this is just coming from this axiom of probability. Also, there's a key thing which is called Bayes' theorem. Bayes' theorem is a pattern. You take this base down here, and you intersect the two available letters, starting with one which starts or comes first in the alphabet. So we're going to have A intersection B given B. That being said, can somebody help us expand probability of B given A? Given A, what comes down?
Probability of A.
Of A, and what do we have on top?
Probability of B intersection A.
Probability of B intersection A. So this is a very key axiom of probability, which is simply like special paper 1 is a pattern. All right. So suppose I asked you to find the probability of A given B given A complement. Who can expand this for us? Who can expand that for us? So this is what comes down there, a complement. And here we're going to have the probability of what? B intersection A complement. What is a complement? A complement is what is outside. So A complement is simply 1 minus the probability of A. What do I mean by outside? If A is 20%, what is remaining? 80%. So that is what we call complement. B is 10%. What is the complement of B? 1 minus 10% or 0.10. We get 90% or 0.9. Quick, can you remember? What did I say? The complement of A? What is the complement of A?
1 minus probability of A.
minus probability of A. Right. So if A is 20%, what is the complement of A? What is the complement of A?
80.
80%, correct. Or 1 minus 0.8, 0.2, which is 0.8, correct. Also mentioned a complement. If we're given A given B, how do we expand this?
You write over
Start with over,
probability of B on top there, probability of A intersection B.
Correct.
Yeah.
So suppose you're told that the probability of A given B is 0.5. The probability of A is 0.2. The probability of B is 0.3. How do we find the intersection? Just substitute what we have here. What have we been given? Probability of A given B is what? 0.5. Intersection we don't have. What is the probability of B? Probability of B is 0.what?
0.3.
So just cross multiply. So our A intersection B is therefore going to be equal to what? 0.5 times 0.3, which gives us 0.15. Together?
Yes.
All right. So there's another good theory, which is theorem 2. Probability of A is simply given by A intersection B plus A intersection B, but the complement will be on the other letter. So if this is A, we'll put the complement on B there. Let's try. Suppose it is B. Who wants to give us the formula? It's A intersection B plus A intersection B, but this time the complement will be on which letter? If B is subject, the complement will be on which letter? The other letter, A. A was subject, the complement will be on the other letter, which is what? B. Get that idea? All right. Then we also talked about the union set, A union B. Remember, what's the formula for A union B?
Probability of A plus probability of B plus probability of A intersection B.
Okay.
Sorry.
So probability of A plus probability of B minus the intersection of what? A intersection B. Correct. When we make this substitute formula, we're going to have what? Probability of A intersection B is the same as what? Probability of A plus probability of B minus the union set of A and B. So far on these axioms, anyone behind? Are we on the same page? Okay. Now let's go to an exam question. We're given the following parameters. Okay. So let me just put this on one page so that we can work it out together. So we're told that number one, consider an insurer that offers two types of policies. There's a home, a car insurance policy. So these are the two policies that we have: home and what? And car. So we can use our own letters to say home and what? H, and car can be what? C. So 87% of all customers have a home insurance. So what's the probability of H? It's 7%, so 0.87. The car insurance, we thought that 96% of all customers have a what? Car insurance. So this is 0.96. What else are we taught? What else are we taught? That at least every customer has at least one of the two. So H union C.
So iyo naraisha mmako kwe number director mupange decision.
Okay. So now, with the parameters that have been given, let us calculate. Calculate the probability that a selected customer does not have car insurance. What are they asking for here? Part one, the probability that one does not have a car insurance. So what are we looking for?
Complement.
Complement of what? Of C. How do you find the complement of C?
One
1
minus
minus 0.96.
Probability of C, which is 0.96, to give us what? .04. Are we all agreeing?
Yes.
Okay. In part two, what is the probability that one has car insurance and a home insurance? Word end is the same as intersection. Union goes with all. So find the probability that he has a car and home insurance. So probability of C union what? H. How do you find the probability of C intersection H? We say that this is the same as probability of what? A plus what? Probability of what? Probability of C plus probability of what? H minus what? Union. If this is intersection here, we put union. C union H. All right. What is the probability of C? 0.96. What is the probability of H? 0.87.
87.
And what is the union? 1. So what do we get? 96 plus 87 minus 1. 0. What? .83. Then question number 3. What is the probability that he has a home insurance given that he has a car insurance? So probability of H given what? Given C. So who can expand this for us? What is H? B and C. We can expand
Right over
over.
probability of C.
Mhm.
On top there, probability of H intersection C.
So what is H intersection C?
0.83.
Same as C intersection H, yes, 0.83. So if you get this wrong, you also get this wrong. And what is the probability of C? .0. So when you divide that, what are we getting? 0.86. Okay, then lastly, I told that what's the probability that he does not have a car insurance given that he has home insurance? Can somebody give us a notation? What is the notation?
It's a probability car insurance complement
Mhm.
given home insurance.
Great. Then how do we expand it? It comes down there. H.
Probability of home insurance.
Then on top,
Probability of complement of car insurance intersection home insurance.
all right. So whenever you have this scenario, just know that we need to use theorem what? Theorem 2. The complement is on C, meaning the subject of the formula must be H. So H is equal to what? Probability of C complement intersection H as the probability of C complement, no, C intersection H. But here you ask yourself, if H is subject of formula, complement should be on the other letter, which is what? C. All right. So this is very important. I repeat. The question is asking us to find the probability that it does not have insurance, even as home insurance. So we are saying probability C complement even H. This is easy. So you're going to say C complement intersection H over probability of H. How do we know which rule to use now? Whenever there's a complement inside there, you can try them, try and error. Start with H, we can start with C. So here, whenever you're doing theorem 2, you're just adding two intersections. C intersection H plus C intersection H. In here, C intersection H plus C intersection H. You swap now. Where there is C, where there is H, the complement should be on the other letter. Where there is C, the complement should be on the other letter. Which one do we pick? One that has what we're looking for here. So this one with the complement on C, so we're going to pick this one. Now, having decided that, let's now substitute. The probability of H, we have, yes, probability of H is 0.87. So here you put 0.87 is equal to, this part we don't know, C complement intersection H. But the complement, with the intersection we found of C intersection H was 0.83. So here we put 0.83. So we make this subject of the formula. So how do you find the probability of C complement intersection H to be 0.87 minus what? 0.83, which is 0.04. So this is what we're going to put here. 0.04. The probability of H was 0.87. This one was a tough one because you needed to think very much. So when you divide that, you find 0.04 over 0.87, which is 0.046. That would be your final answer. So if you don't know the theorems, you can't know where to start from. Right, so we have question 2. In this study, we're asked to compare teaching method of 20 children which were divided into 2 groups. Each group was taught reading using one method. After 6 months, the 2 groups were given the same test. One pupil, the first group was ill and missed the test. The scores are showed below. So there's method 1, missing 1 pupil, method 2, or 10. So we're being asked to calculate the extreme values, the quartiles for each group, 7 marks. So remember, this is topic 1. How do we find the extreme values? And how do we find quartiles? Okay, can anyone lead us? Who wants to try to take us through? I was teaching this yesterday. Anyone? Okay.
Hi, Collins. Yeah,
Hi.
apologies. I'm on the road, but what it is we need to arrange the information, and once we arrange the information, we need to calculate we need to calculate the quartiles, which is the first quartile being a quarter of n plus 1, which is going to help us to determine the position of the first quartile. Then this the median will be calculated by half n plus 1. Then also we are going to use the 3/4, which will be our third quartile, 3/4 of n plus 1 to give us the third quartile. Except before all that, we need to determine the range, which will be the x max minus the x mean values, which is going to help us to determine the outliers when multiplied with the 1.5 correction term.
Thank you so much. So it has impressed me. So we rearrange them in order, starting from the smallest to the highest. So this is the method that has been given. So we're going to rearrange them. So rearrange them, we start with 50, 71, 73, 76, 79, 80, 81, 85, and 89. So the extreme values, firstly, for us to identify, the lowest value is 50, the highest value is 89. So how do we find the median? The formula for the median is what? Half n plus 1. Half n plus 1. Okay, so our numbers are what? 9. 9 plus 1 is 10. So half of 10 is what? 5. The fifth position will be as follows: 1, 2, 3, 4, 5. So this is going to be our median. So 79 becomes our median because we calculated it as follows. Together so far?
Sorry, are you writing or just explaining?
Writing. Oh,
Oh,
I wasn't beaming. Writing. I need to repeat that. So we rearrange our figures. The smallest 50, 71, 73 up to highest number. So to find the median, it is half of n plus 1. So our n was 9. 9 plus 1 is 10. So half of 10 is the fifth position. So 1, 2, 3, 4, 5. So this is the fifth position. And this becomes our what? Our median. How do you find the lower quarter? Lower quarter is given by what? Q1. All right. So Q1 is quarter of n plus 1. So a quarter of 10 gives us 2.5. Now, whenever I have a 0.5, it means this number and what follows, you divide by 2, average it. If you have 2.25, you just get 2. 2.75, you get 3. 2.5, the second number, the third one, you average them. So when you go here, 1, 2. The second number and the third one, you add them, you average them. So this gives us 144 divided by 2, which gives us 72. So how to find the
Come
upper
again
quartile?
on that one. Hello?
Yes, please.
Just come again. You said we found 2.5. So rounding off the 2.5, we get 3. And then
If you find 2.25, round off to get a what?
a 2. Yes,
You get 0.75, you round off to get a what?
a 3.
A 3. If you
Yes,
get a 2.5, you don't round off. You get the second number and the number that follows, which is the third number. You get the average. At
I see.
17.5, you get the 17th number and the what? 18th number. And you add them and divide by 2. So here, since we're at 2.5, the second number and the third number, divide by 2. Is that clear?
And then, so if we got a 3, we're just going to get the third number. That's it. No,
Exactly.
any.
Yeah, exactly. Right. So how do you find the upper quartile? Q3.
Three
Find the upper
quarters n
quartile
plus 1.
formula.
Is it three quarters?
3
n
quarters.
plus 1.
Yes,
N
3
plus 1.
quarters of n plus 1, correct? So what is 3 quarters of n? What is 3 quarters of 10?
Seven 7.5.
7.5. So what do we do? 7.5.
So we are going to find the number between 5 and 8, I think. I mean 7 and 8.
It's the 7th, and the following number is the 8th. So this is 5th, 5, 6, 7, 8. So the 7th is what? 81. The 8th is what?
85.
5. So when you add this,
Then over 2.
over 2. So 81 plus 80. 5 divided by 2. That's how we get the 60, right? The 83. All right. So you do the same for method 2. We arrange them in increasing order. These ones are n. So we increase them to find the lower quartile. Extreme values firstly. The lowest value was 61 and the highest value was 81. So the lower quartile is n plus 1. So here 10 plus 1, since they are 10 divided by 4, we get 2.75. This one we round it off to the third position, which is 60 what? 62, if we're going to count them. The third position, 1, 2, 3. So this is our first quartile. We find the second quartile, which is the median, n plus 1 over 2. So 10 plus 1 is 11, divided by 2 is 5.5. So what do we do to the 5.5? We get the fifth, the what? 60th position.
60.
When you add the 2, divide by 2, we get what? 73. You do this for this upper quartile as well, 3 quarters of n plus 1. When you get this, quarters of n plus 1, we're going to get 80 what? 82.25. 8.25, you just get the eighth number directly, which was 76. So the box-Whisker plot has 6 important parameters. Number 1, the minimum value of x. Number 2, the maximum value of what? Of x. So in the first method, the minimum value was 50 and the maximum value was 89. And the lower quartile was 72, we were at 79 and 83. So how do we find the interquartile range? We subtract the upper quartile minus the lower quartile. So 83 minus what? 72. So what do we get? We get 11. So interquartile range is 11. 11 multiplied by 1.5. 11 by 1.5, what we get? 16.5. So 16.5, you add it here, and 16.5 you subtract it there, so that you identify the outliers. That is how we identify outliers, if any. Repeat. First, find the interquartile range by subtracting the highest minus the lowest quartile. The answer is 11. The standard value of 1.5 is what you multiply to that interquartile range, which is 16.5. So 16.5, when you add it to this figure there, we get what?
99.5.
91.5.
99.
99?
99.5.
99.5. And from this figure, you subtract the 16.5, what we get?
How much of- 55.5.
55.5. Where's 55? Here, right? Somewhere here. So it means the 50 is outside the box, so it's called an outlier. You do the same for me, method 2. How do we find? So the values, these ones are just the minimum value of the intervals. The smallest number was 61. Highest number was what? 81. And Q1 was 62. The quarter range was 73, and upper quarter was 77.5. So how do we find the interquartile range? Anyone? IQR, how do you find it?
We subtract Q3 minus Q1.
You get what?
We get 15.5.
15.5.
Yes.
What do we do to the 15.5?
We multiply it by 1.5.
0.5 to get what?
23.25.
23.25. And 3.25 is a correction term. What do we do it on the upper half? The upper figure, what do we do?
Upper figure we add.
We add to get what? 100.75.
100.75.
In the lower figure, what do we do?
Subtract
We
it.
subtract
62 minus what? 23.5 to get what? At 8.75.
75.
And here, do we have an outlier?
no.
No,
Yeah.
all of them are inside.
Also my inside the fences.
So what is the difference between the two groups? Number one has an outlier, okay, of 50. So when they ask you, explain in that range, okay. One has an outlier. So this was basically in the deferred test that was last semester. It was distance or time? I do not know. Verify. So those who got the pamphlet, I think this is already there in the pamphlet. You can go through. If you pay for the pamphlet, please remind me I need to send it to you tonight or tomorrow. Okay.
You pay for it to get the solutions?
Yes.
How much
Those,
is that?
it's 250. There are those who are paid
Oh,
for the pamphlet. The questions I've given all of you, but others who are getting. Okay. So that is with regards to question to do with let's look at another question for frequency distribution. I've seen most of you are doing very fine on this one, unless there's anyone who's behind. So normal distribution, we did this question over lunch. So I would want us to look at something that I've covered. Okay, this one here. The company has 4 locations at which customers were surveying the satisfaction of the rating. Below are the average ratings for the 4 locations. So we're given the location 1, 2, 3, 4, the average, and the number of customers. So how do we find average? Average is simply the mean. Anyone who wants to help us do this question? So this can be called a frequency. This can be called a midpoint. So multiply the frequency times the midpoint. Total we get is a summation of fx. And the mean is found by what? Summation of fx divided by the total frequency. So we need to total up this frequency here so that we are able to get. So let's multiply this by that, this by that. So 7.8 times 117. What are we getting?
912.6.
912.6. The next one.
731.
731. Okay. Then
448.8.
448.8.
666.
666. So the total, guys can do the total here. The ladies can do the frequency total. So what are we having? $117 plus 86 plus 68 plus 90,
261.
361.
Mhm.
And here, what's the total?
2758.
Huh?
Not true.
2758.4.
4758. What?
No, 27.4.
2758.
0.4.
274.
Hmm?
8.4 like this.
Yes, that's what I found. Like that.
Okay.
2758.4. Yeah.
2758.4.
Yeah.
Also put that. So how do we get the mean? 2758.4 divided by what? 361.
3.
Divided by 361. What do we get?
6.4.
7.64. So that is what we call our mean or the average. We find it by that. So 3 marks. Okay. So we'll end here. Our revision will continue tomorrow up until Monday when our test commences. So a little does it.
Time is it tomorrow?
Tomorrow in the evening, I'll be at church in the morning, so we'll only meet in the evening so that we can cover much. I'll look at binomial, distribution, and normal, and Poisson maybe, if he has thought. And that is what is remaining. We are ready for
I
the,
don't think he taught Poisson.
so we do binomial and normal. All right. Is there any questions?